Hello friends, today we are going to discuss how to solve factorization problems. Factorization problems are encountered in school level right from class 7 and 8. So this is a very common topic throughout the high school. First of all, factorization problems which normally comes in school, they can be divided into quadratic, cubic, and also biquadratic. So generally the factorization problems which we all see in our school exams in various school textbooks, they are either quadratic or cubic or biquadratic. I think most of us are aware that quadratic factorization problems are generally done by middle term factorization. So middle term factorization is the most common way to do quadratic problems. Like say for example, if you have x square minus 11x plus 30, in that case you can simply write 11 as 6 plus 5. So it will become x square minus 6 plus 5 into x plus 30. So ultimately it becomes x minus 5 into x minus 6. So this is the very well known middle term factorization to factorize a quadratic expression. In case the middle term method does not click your mind, there is one other alternative, that is known as completing the square. So basically for x square you write x, for minus you write minus, and whatever is the coefficient of x, you write half of that. So the coefficient of x is 11, you write half of that. And you will realize that if you expand this, the first two terms will be x square minus 11x, and you will get an extra 121 by 4 which needs to be subtracted. So this will become x minus 11 by 2 whole square minus 1 by 4, which in turn becomes x minus 11 by 2 whole square minus half square, and finally this becomes x minus 11 by 2 plus half into x minus 11 by 2 minus half, and you can clearly see that the result of this is going to be the same as what we saw earlier, x minus 5 into x minus 6. So you can either do middle term factorization, but if that doesn't click your mind, you can also do it in this other alternative way. So there are two ways to factorize quadratic expressions, either by middle term or by method of completing the square. Now you all will feel that this method is much more easy, so why do we need to go into this method at all? But there are some complicated questions, so we'll have a look at those now. There are some complicated questions. For example, look at this one. Suppose you are given a factorization x to the power 38 plus x to the power 19 minus x square plus 3x minus 2. Suppose you are asked to do this. Now you may say that this is neither a quadratic or a cubic or a biquadratic, but just see one thing. If you take these two and these two together and try to complete the square, so for x to the power 38 you write x to the power 19, instead of x to the power 19 you write half, and then you give a square. For x square you write x, instead of 3 you write half of 3. So this is what you will get. You can see that when you open these two brackets, 1/4 and 9/4 cancels to give -2. So you will see that this method of completing the square is a very versatile method. You should not restrict this method only for solving quadratic. You can use it in some other situations like these. So now it's become a very straightforward x to the power 19 plus half plus x minus 3/2 into x to the power 19 plus half minus x plus 3/2. So this is the answer of this particular question. So we were discussing how to solve quadratic factorization. What about cubic? Let's have a look at cubic factorization. So suppose we have a factorization like this: x cube minus 6x square plus 11x minus 6. Suppose you have a factorization like this. Now when you have a factorization like this, you must consider the constant term in the cubic. So the constant term is 6. Consider all the prime factors of 6 and consider them with a plus sign and a minus sign both. Consider all the factors of 6 with a plus sign and minus sign both. So suppose if you consider 1, so it will become 1 minus 6 plus 11 minus 6 is equal to 0. If you consider 2, 8 minus 24 plus 22 minus 6 is equal to 0. And if you consider 3, 27 minus 54 plus 33 minus 6 is equal to 0. So when I put x equal to 1 or x equal to 2 or x equal to 3, in all the three cases I am finding that the result is a 0. Now according to this method, it's very famously called vanishing method. The ultimate answer will be this: x minus 1 into x minus 2 into x minus 3. So once again I repeat, you need to factorize the constant term and fit each value into the expression and see for what values you get a 0. Those values will help you to factorize the expression. Now in this technique I have chosen a cubic which is factorizable into 3 linear factors. Suppose let's say we have a different kind of a cubic. Suppose we are asked to factorize x cube plus 1. Suppose we are asked to factorize x cube plus 1. So you can see that 1 has only one factor, that is 1, and I told you that you are supposed to consider it with a plus and a minus. So if you put x equal to minus 1, this expression becomes 0, right? So that means x plus 1 is a factor. So you divide x cube plus 1 by x plus 1. So if you divide x cube plus 1 by x plus 1, so this will be x squared, so x cube plus x squared. Then you subtract. So finally this is x plus 1 and this is x square minus x plus 1. So this helps us to complete our factorization: x plus 1 into x square minus x plus 1. So I repeat once again, if you find that there is only one linear factor, you can be rest assured that the other one will be a non-factorizable quadratic. So to obtain that other factor, you just need to divide the cubic by its linear factor. Automatically you will get the other factor. So these are the two ways in which you can solve a cubic. Now let's have a look at biquadratic. Now as far as biquadratic is concerned, let's understand that the previous method which we discussed, the vanishing method, is also applicable over here. So you can see that the constant term is 1. So you can try plus 1 and minus 1. If you put x equal to 1, then it's not 0. But if you put x equal to minus 1, you will find that it is 0. So we are definitely in a position to apply this technique. So what we'll do is that we'll just divide the whole expression, and let's see what we get as a result of this division. So we are dividing that entire expression by x minus 1. It should be dividing by x plus 1. So when we put x equal to minus 1, it's a 0. So we should be dividing it by x plus 1. So when we divide it by x plus 1, we are getting another expression which is a cubic. So we are getting x plus 1 into x cube plus 4x square plus 4x plus 1. So far this has been factorized to this. Now, since this is a cubic, we are now in a position to apply the techniques that we discussed for cubic. So you again put x equal to 1. And you will see that it is not 0. Then again you put x equal to minus 1, and you will see that it is 0. So that means we can repeat whatever we did with this cubic also. So x cube plus 4x square plus 4x plus 1 divided by x plus 1, it gives a 0 remainder. So we get x plus 1 whole square into x square plus 3x plus 1. So this is the first kind of sum in biquadratic. Now it's pretty clear that you are not going to get a linear factor every time. So the previous biquadratic which we discussed, luckily we got some linear factor, but you are not going to get a linear factor every time. For example, look at this. If you put x equal to 1, it's not 0, and if you put x equal to minus 1, then also it is not 0. So that means the linear factor thing is not working over here. So we'll have to think of some other method. So what we will do is we will in such cases usually try to pair the third degree and the first degree term, So if you pair the third degree and the first degree term, you will get 5x into x square minus 1. And in the meantime, you will notice that these three can be together written as x square minus 1 whole square plus 6x square. Now, this is a very interesting development. You will notice that what we have got here is basically like a middle term factorization. If we put x square minus 1 as a, then ultimately the question becomes a plus 2x into a plus 3x. So the answer of this question will be x square plus 3x minus 1 into x square plus 2x minus 1. So let's have a look at this sum again. You may encounter such a question where putting x equal to factors of the constant does not give us 0. In such cases, we usually pair the third degree term with the first degree term and we proceed like this. That is what we normally do. Let's have a look at this particular question. It is also a fourth degree factorization. X minus 1 into x minus 2 into x minus 3 into x minus 4 minus 120. So you may have noticed, thanks to the previous question, that it usually makes sense to pair the smallest with the biggest and the two middlemost. So if you pair these two and these two, let's see what you get as a result of that. So you get x square minus 5x plus 4 into x square minus 5x plus 6. Now if you take x square minus 5x as a, so you get a plus 4 into a plus 6, so that's a square plus 10a minus 96, and after factorization it gives a plus 16 into a minus 2. So x square minus 5x plus 16 into x square minus 5x minus 2. So this is what we get in this particular case. So we have had a look at a few sums of fourth degree and how we should proceed in these cases. Now the thing is that suppose you have a fourth degree expression like this. Suppose we have an expression like this. Now remember one thing, this is belonging to a format a to the power 4 plus b to the power 4, which can be readily written as a square plus 2b square whole square minus 4a square b square, which finally becomes a square plus 2ab plus b square into a square minus 2ab plus 2b square. So this is the answer that we get out of this. So when you get a question like this, immediately it strikes you that this is of this form, which can be factorized in this manner. So we just need to proceed accordingly. So what you need to do is you need to write that this is x plus 1 whole square plus 2 into x minus 1 whole square minus 4 into x square minus 1 whole square. So once we have got this, the two factors will be x plus 1 whole square plus 2 into x square minus 1 plus 2 into x minus 1 whole square into x plus 1 whole square minus 2 into x square minus 1 plus 2 into x minus 1 whole square. Well, the rest of it is pretty routine. You just have to expand all the terms inside this bracket and all the terms inside this bracket. So this is a very well-known biquadratic factorization. Factorization of the form a to the power 4 plus b to the power 4. You will notice one thing, that all the biquadratic factorizations which we have discussed till now, they all have a particular variable. In almost every case that variable is x. Now suppose you are doing a factorization where there is no particular variable. So let's say you have a factorization 2a square b square plus 2b square c square plus 2c square a square minus a to the power 4 minus b to the power 4 minus c to the power 4. So you will notice that immediately there doesn't seem to be a particular variable in this question, because it's pretty clear that a, b, c are all three different parameters in this question. So how do we proceed when a question like this comes? So suppose we begin like this. We begin by writing the entire expression in descending powers of any one. So you write the entire expression in descending powers of a. So what I did was I started with this expression, wrote it in this manner and then again in this manner. So the term inside this bracket can also be written like this. So we are getting 4b square c square minus a to the power 4 into minus 2a square into b square plus c square plus b square plus c square whole square. So like I said, we first wrote it in descending powers of x and then we factorized, we simplified some part of the question and ultimately bring it to this stage. Two bc whole square minus a square minus b square plus c square whole square. Now after bringing it to this stage, we just need to proceed like this, 2bc plus a square minus b square plus c square So now what we do is we write a square minus b minus c whole square into b plus c whole square minus a square. So once we do this, we get our four factors: a minus b plus c into a plus b minus c into b plus c plus a into b plus c minus a. So these are the four factors of this particular expression. So it is an example of a biquadratic where there is no particular variable, where a, b, c, all three of them can be considered as the main variable and proceed accordingly. So that brings us to an end of this session of how to solve factorization problems.